Hello, my name is Sam Gallowell, and today I will be showing you how to solve systems of equations. So I have some examples right here which we're going to be using. So first, we have 3x minus 2y equals -4. It's a nice simple equation, but it is impossible to solve for the second one. So our second one will be x plus y equals 7. So the first thing you need to do to solve a system of equation is to isolate either of these variables. For this example, I will be isolating x, and you should know how to do this from grade 9. So x equals 7 minus y. Now that we've got our x, so we would substitute it into the previous equation. So 3 bracket 7 minus y minus 2y equals -4. So, first thing you need to do is expand, and you should know how to do this from grade 1. So, 3 times 7 is 21. So, we can just select, so we don't need this 3 anymore. So, we can just do 21, it's bad too, 21 minus 3y minus 2y equals -4. So, now that we have this, we can actually solve. Solving should be simple. It's just what we've done last year, so I'm going to cut to when I've got a simplified version of this. So, now that we've got our simplified equation, we can now actually solve it. So first, you'd move this here, like we learned in grade 9, and you'd end up with this. 5y equals -25. You then divide both these sides by -5. Again, this is all stuff from grade 9. You should know how to do this. We now have y equals 5. So now that we have our y variable, we need to go back to one of the previous equations and substitute in our y so that we can then find our x. For this, I'll be using the I'll be using the equation wherein I found our x, where I isolated our x variable. So let me just cut to that. So having substituted y in for what it is, which is -5 in this case, because our y is negative in this equation, it becomes simple addition. Now keep in mind that you don't need to use this one equation when you isolated it, but it does tend to be more useful, and it saves time. So, to prove that our answer is correct, first I might add that x equals 2. So, we would write out our answer like 2, 5. There's a comma in between there, but it looks messy, and I'm sorry about that. So this is our complete answer. X equals 2 and y equals 5. Now, we can prove this by either plugging these numbers back into an equation, or they should be, if you were to graph lines where if you were to graph lines using x and using the two equations as your equations for lines, you will end up with the point of intersection between these two lines as those two numbers. And to prove it, I'm going to show it to you on Desmos. So, here we are on Desmos, and as you can see, I've graphed the two lines here. The blue line represents equation where 3 is the equation 3x minus 2y equals -4. And the red line is x plus y equals 7. As you can see, they intersect at 2, 5, which is the exact answer we got when we did it algebraically. So, finally, what could these lines in this question represent? So, for that, I'm going to say... So, for this example, let's say the blue line represents fish jumping out of the water, and a red line represents the, fish or bird actually plunging into the water. I think they're called kingfishers, and this is where the bird catches the fish. If we say 0 is when the fish is out of the water, and when we say, if our x line equals the water level and our y line equals height in meters, I know that it isn't very realistic for our fish to actually be jumping that high, but this would be the point where the pelican or whatever catches the actual fish, and then it would be when it's 5 meters in the air and 2 meters from, I guess, the shore. I don't know. The shore. Bye, and thank you for listening to my explanation of solving systems of equation both algebraically and using graphs. I'm Sam Gallo. This has been a pleasure.